Hey you guys, we're going to be talking about arithmetic sequences today. This is just going to go in your notebook. And we talked yesterday about sequences kind of in general. And what we've got here is a sequence that looks like this: negative 3, 5, 13, 21, 29. So to kind of review some important points, remember when we write a sequence, we have names for each of the terms. Okay, so this is A1, and then A2, and then A3, A4, A5. Those are each of the terms. Okay, and so another way to think of it is negative 3 is the first term, 5 is the second term, 13 is the third term, 21 is the fourth, 29 is the fifth. So first, here, like looking at the sequence, can we figure out what the next three terms would be? Well, if you're following it, if you kind of notice, what's happening is it's at 8 is being added each time. And so what the next three terms would be, I just need to add 8. So 29 plus 8 would be 37, plus 8 would be 45, plus 8 would be 53. Okay, and that would be the next three terms. Now, this idea of the common difference, that is just what are we adding or subtracting each time. Okay, common because it's each term has that in common with the next, and then difference means the difference between. Okay, well, the best way to find that common difference is to take a term and subtract the one before it. So I'm going to pick, since I don't want to deal with that negative number, I'm going to take 13 and subtract 5, and I get 8. Which should sound familiar. That's what we added each time, right? That's what the common difference really means. Okay, so my answer is just D equals 8. Now, a formula for this. Here's the harder part. We haven't totally gotten down yet. So there's a couple different ways to think about it, but we're going to see an actual formula on the next page. Okay. So here we'll write down a formula that will help us with arithmetic sequences. It looks like this. A sub n equals a sub 1 plus parenthesis n minus 1 times d. Okay, so that's the formula. And so what's important to note here, a sub n means the nth term, okay, which really means any term in the sequence. In the sequence. Right? A sub 1, that's the first term. Okay. N stays n in the formula. That's how we're going to be able to plug in and use the formula. Okay. And then finally, D stands for the common difference. Okay, that says common difference. My stylus isn't working very well right now. Okay, so that's the formula. So this is something you're going to need to remember, and we're going to use it over and over and over again. So let's try a few examples. Okay, first, find the first 5 terms of the sequence, and I'm giving you here is the formula for the sequence. So in problem A here, it says a sub n equals 3n minus 7. So if I want to find the first term, what I do is I say a sub 1, that would be the first term, equals 3 times 1 minus 7. And then I do the math. 3 times 1 is 3, minus 7 is negative 4. And we repeat this process. A sub 2 would be 3 times 2 minus 7, which is 6 minus 7, which is negative 1. Okay, we'll keep it going. A3 is 3 times 3 minus 7, which equals 9 minus 7, which equals 2. At this point, you might notice there's a pattern. We're adding by 3 every time. Okay, so what that means is a sub 4 which should be 5. Let's check. 3 times 4 minus 7 is 12 minus 7 equals 5. And so then a sub 5 we should know is 8. So the first 5 terms, there we go, we found them. All right, for problem B, we've got another formula. This time it's actually in that format from what we wrote down on the slide before. So in this situation, there's a couple things we can do. We're going to plug in values for n, and if we do them right away, it works just fine. And you end up plugging in like 1 minus 1 and you get 0, and then you get 1. 2 minus 1 is 1. But one thing that can make our life a little easier is to actually go through and rewrite this so that it looks more like problem A. So to do that, I'm going to distribute the negative 10. All right, so I'm going to get negative 2 plus negative 10n plus 10. Because when I distribute the negative 10, I get negative 10n, and then negative 10 times negative 1 is plus 10. And then I have like terms there, so it's really negative 2, well, I have negative 2 plus 10, and so that makes it 8 minus 10n. 8 minus 10n. And now it's a lot easier to actually just plug in and get the first 5 terms. So we'll do this again. We'll go a1, and we go 8 minus 10 times 1. Again, when n is 1, we plug in 1. So that's 8 minus 10, which is negative 2. And then a2 would be 8 minus 10 times 2, 8 minus 20, which is negative 12. a3, 8 minus 10 times 3, 8 minus 30, well, that'd be negative 22, and you can kind of see the pattern. a4 would be negative 32, and a5 would be negative 42. Okay, so given a formula, we can just plug in values for n in order to find the terms. Now what we're going to do is, given some terms, we're going to try to write a formula. So here we have a couple of problems. We'll start with number 1 here. Write a formula for the sequence. So the sequence here is 24, 20, 16, 12. So in order to do this problem, we need to first remember what the formula rule is. So our arithmetic formula is an equals a1 plus parenthesis n minus 1 times d. Okay, and we got to remember that a1 is the first term. I don't know what that n is doing there. The first term. And then d is the common difference. Okay, so that's what we need to find. We need to find the first term and the common difference. And if I look at problem number 1, the first term is easy to find. It's 24. That's a1. Then the common difference, what I'm doing is I'm looking for how do I get from one term to the next. And sometimes it's pretty easy to spot. Here I'm subtracting 4 every time, which means that my common difference is negative 4. So to do this equation, what I'm going to write here is this formula, but plugging in for a1 and d. So I'm going to write a sub n equals first term, 24, plus parenthesis n minus 1. Notice that stays. We don't plug in for n, times d, which is negative 4. So times negative 4. And now to simplify it, because what we want to do is write it as the simplified version, I'm going to distribute the negative 4. So I get 24 minus 4n plus 4. Just pointing out, I distributed the negative 4 there. That's where negative 4n and plus 4 came from. And then I have those like terms, so I get a final answer of an equals 24 plus 4 is 28 minus 4n. Or you could write it as negative 4n plus 28. That should kind of sound familiar. It sort of seems like slope-intercept form, like y equals mx plus b. And that's kind of what it is. The common difference is like a slope, and this 28 is sort of like a y-intercept, which would be a0 if there was such a thing. Okay. For problem 2, I'm given a1 and d. So instead of having the actual terms, I'm given the first term and the common difference, which means I just plug into the formula. Super easy. So we go an equals negative 10 for a1 plus parenthesis n minus 1 times 5 for the common difference. And then we're going to distribute the 5, and we get negative 10 plus 5n minus 5. And those are like terms there, the negative 10 and the negative 5. So our final answer is an equals, that's negative 15 plus 5n, or 5n minus 15. Okay, let's try two more. All right, problem 3 here is interesting. So what I've given is a3, a4, and a5. So I don't have the first term, but I know it goes 7, then 5, then 3. So one thing we can determine right away is that the common difference is negative 2. Because as I go up in the sequence, the terms are going down by 2. So I know D equals negative 2. I need to find a1 for the formula, right? a1 equals what? It looked like a 2. a1 equals, we don't know yet. So I have a couple ways I could do it, but one thing that would be smart to do is to just work backwards. a2 equals, and then a1 equals. So a2 equals, adds up, and then a1 equals. So if we're going backwards, before 7, I would add 2. So I'd get 9, and then I'd add 2, and I'd get 11. So now I know my first term is 11. So I can write my formula. a1 equals, excuse me, I should say an equals a1, which is 11, plus n minus 1 times the common difference, which is negative 2, and then distribute 11 minus 2n plus 2. So my final answer, an equals 13 minus 2n. Right, and that's a formula that represents this sequence. I could plug in 5 and I should get 3. So a5, let's try it out. Let's check our answer. a5 equals 13 minus 2 times 5, which is 13 minus 10, which is 3. So it worked. All right, finally, a1 equals 110 and a5 equals 190. So I've skipped a bunch of terms. So in this problem, all right, I already know a1. So for my formula, I have a1 equals 110, but I don't know the common difference. So I have to try to find that. Well, if you remember, the common difference is actually, we talked about it earlier, is like the slope. And so we can find this common difference using the slope formula. And so if you remember, slope was like y2 minus y1. So the values of the terms are like the y's. So I'm going to go 190 minus 110 on top. And I'm going to go 5 minus 1 on the bottom, because those are like the x values. So it's kind of like we have x and y. And so when we do that, it's 80 over 4, which equals 20. And so now I know my common difference is equal to 20. So I can write a formula, and that would be an equals, first term, 110, plus n minus 1 times 20. When I distribute the 20, I'm going to get 20n. And then, let's see, I have 110, and this is going to be minus 20, so it's going to be plus 90 as my final formula there. All right, that's all. Thank you for watching.